Hi, everyone, and welcome to Lab 2 on probability and statistics. So we're going to continue our work with how to use statistics and generate probabilities by actually doing a lab and seeing how this works in real life. So to start us off, I would like to do a little simulation of normal distribution. All right, so we talked about normal distribution in class, where we said if you have a large enough set of data points, they will tend to cluster around the center of the data. So here, for example, you see this picture of a pegboard with balls coming down, and you also see a bell curve beneath it of where those balls are landing over time. And with large enough numbers, what you'll see is you'll get more balls in the middle and fewer towards the end, and it generates this nice bell curve or normal distribution that we've talked about. Okay, so let's take a look at what this actually looks like. So here I've got one of these pegboards, and if I click play, I'm just going to drop one ball down, and it kind of randomly bounces around and ends up somewhere on the bottom. And it could end up in any of the bends, but has a greater chance of ending up near the middle. And if we do it, let's do it now for 10 balls and see what happens. All right, so you can see with 10 balls, we're starting to get a few more towards the middle, but they're pretty spread out. Now let's do it for 100 balls and take a look at that. So we're starting to get closer and closer to that bell curve shape. 100 balls even is not really enough to get a perfect bell curve. If we expanded it to maybe 1,000 or 10,000, we'd really get something that starts to look like that. But the point to remember is that this law of large numbers says that if you have enough data points, then you will start to form a curve like the bell curve and the normal distribution that we've been talking about. So, in this lab, we are going to actually try using a bunch of the statistical tools that we talked about in class to actually interpret and analyze data. So you're going to apply Google spreadsheet functions to calculate the population size, the central tendencies like the mean, median, and mode, the range, and the standard deviation. And so you'll need to then put that data into histograms. You'll want to think about, are there any outliers in the data that we should consider whether we want to include or not? And these are all great skills for engineering in general. As engineers, we use them all the time. So what we're going to do is we're actually going to take the data that we entered into the spreadsheet last time in lab 1, where you measured the characteristics of a couple of different objects, and we're going to use the spreadsheet's built-in functions to calculate these descriptive statistics. Okay, and then we will actually build histograms. We'll make sure that they have the appropriate bin sizes and number of bins based on the data range and the distribution, and then generate those histograms in the spreadsheet. Okay, so the procedures, first of all, let's go and look at this linked lesson before we start the lab procedures. Okay, so I clicked on that link, and what I get is this nice document giving us some examples of how to really use the descriptive statistics methods in Google Sheets, okay? So in this case, we're going to use this data that's here in this document for this example. And what we're doing is we're estimating the number of ball bearings in say, a jar or some container. And you can see each student created their estimate of the number of ball bearings. They seem to all kind of cluster around 1,100 or so. And then we've got one student who created a much larger estimate, 419,000. So potentially is an outlier that we might want to consider. You know, it has a value greater than the other values by an order of magnitude, or that's a factor of 10 times. And so probably we're going to want to set that bit of data aside. Now, do remember what we said in the class. You'd never want to modify your original data. So always save a copy of your original data, and then when you in your new copy, you can do things like discard outliers or so forth. Okay. So population is the size of the data set. For our example data here, we have a population count of 16 because there are 16 different entries in our table. And normally we like the population count to be larger than that, at least 20 or 30. Now, so in this example, since it falls below 20, that means it's difficult to draw a lot of conclusions from it. Now, also remember, if the data set were much larger, say thousands or millions of data points, then we could choose a subset of that data, and that subset would be called a sample. And then our sample would use some slightly different statistical calculations versus the population. We also have lowest and highest values in the data set. So those are just the smallest value and the largest value. And we use those when we're trying to calculate the range for histogram setup. Median is the middle value, right? So if you take all of the values and you sort them from smallest to largest, then the median is the one that's directly in the middle. So if you look at this labeled copy of our data set, here it's been sorted from smallest to largest, so 1082 up to 419,904. And the data that is in the very middle of the set is 1100, so that is our median value. And we've gone ahead and marked the 419,000 as an outlier in this data set. Then the mean, or sometimes called the average, is the sum of all the values divided by the number of values. So for the example data, the average would be 1138, and that's discarding that outlier, remember. Now that's for the example data, this is closer to the actual value than the median, but that's not always the case. If you have a lot of data that's very spread out at both ends of the bell curve, you could have average data and median data that's quite different. Now, mode we talked about before, that's the value that appears the most often. So in our example data, the mode is 1100 because if we look back, you can see we had 4 separate instances of 1100. So that is the mode. Now, one thing to be aware of is when you have numbers that are fairly round, that estimation could be due to round number bias. And what that means is we as humans tend to say round numbers as estimates more often than we do not round numbers. Okay, so there's this great example that I thought was interesting. In March of 1856, Earth's highest mountain was publicly declared to be 29,002 feet to avoid the impression that exact height of 29,000 feet was nothing more than a rounded estimate. Now, it is possible to have multiple modes if more than one value appears often. And you can use histograms to help you to visualize modes, right? So they have a bucket size or a bin size, as we've talked about before, which combines the range of values into each histogram bar. So if you look at the histogram that we have here, this uses a bucket size of 5, meaning there's a difference of well, actually, this uses a bucket size of 10. Error in our spreadsheet here. So a bucket size of 10, which means that there are 10 values inside of each bin. And the data points that are inside each of those bins are represented in the bars, with the bar being the number of instances. So for example, we saw 4 data points that were 1100. And that means that we have a histogram with a value of 4 in that bar. Okay, now when we increase the bucket size, that'll change the way that the histogram actually looks. So in this case, the histogram size the bin size has been increased to 34, and then the number of instances of data points inside each bin recorded as a bar. Now, when we are doing the descriptive statistic functions in Google Sheets, you can use a bunch of built-in functions that are already there. Okay, so for example, to get the number of your population, you can put in a cell equals count, open parenthesis and close parenthesis. And when you put the equal in, if you remember from our last lab, that's telling Google Sheets that you're starting a formula. Count is the name of that formula, And then the parentheses are where any parameters would go. In this case, we don't have any parameters, so it's just an empty parenthesis. Then we also can get the lowest value, that would be equals min, open parenthesis, close parenthesis. The highest value is equal max, open parenthesis and close parenthesis. And then the median would be equals average. The median is equals median. The mode is equals mode. And standard deviation of a population is going to be equals STDEV dot P, open parentheses, close parentheses. Now, each of these is actually looking for a range. So what you're going to do when you put in the formula is inside the parentheses, you are going to put the cells that you want it to look at. And you can do that either by highlighting the cells or typing in the numbers that correspond to them. And I'll show you some examples of that when we go to the spreadsheet. Now, I also want to point out here this standard deviation. So I said standard deviation of a population. So you can see STDEV.P, that .P is signaling that this is for a population. If you did .S, it would calculate the data like a sample. And if you just left off the .S or .P, it will assume that you want a sample and use that formula. So in this lab, we actually have a population because it's all of the data. So we're going to use stdev.p. All right, so let me jump back to the lab itself. Okay, so we read the lesson. Now the next thing we're going to do is open the shared Google spreadsheet where everyone put all of their information in lab 1. Now this spreadsheet actually has been modified, so you only have view access. And when you see it, you're going to want to start by clicking Use Template in the upper right corner. That's going to open it as a new document in your drive, so you get your own copy of it. And you can rename it per the instructions in the lab report formatting guidelines, and then organize it to the location you want in your Google Drive. Maybe you have a Engineering 101/labs folder that you want to put it in. Okay, so that's what's going to allow you to edit it. So if you get into it and realize you can't edit, then you've probably forgotten to make your own copy. Just make sure to click the Use Template and then create your own copy. Okay, so let's go ahead and look at the spreadsheet. Now, one thing to note is my version, of course, doesn't have all of your data filled in. So I just have one sample set of data here at the top, one coin instance. You can see it's for a quarter, and we've filled in the diameter, thickness, etc. What we're going to be working with is the density column. Okay, so we're going to be calculating for the densities all of the descriptive statistics that we just described. So if I go back now to the lab descriptions, okay, it lays this out. So you're going to use the object data from the spreadsheet, calculate the following statistical values for the density column only: population size, lowest value, highest value, median, mean, mode, and the population standard deviation. Okay, so let's just go and take a look at a couple of those. So let's imagine that I wanted to get the population count. I might do something like create myself a little table here, population count, and then next to it, I could say equals, right? To let Google Sheets know I'm starting a formula. Count is the formula that we're interested in using, open parentheses. And it's kind of helpful. Google Sheets comes up and tells me a little bit about the formula that I'm working with and what sort of things it's looking for. So in this case, it's telling me it wants a list of values, which we can put in list format. So just, like cell, let's see, our density starts in K2. So I could put K2, comma, K3, comma, K4, or I can just highlight the cells that I want. So if I wanted, let's say I wanted K2 through 10, right? I highlight them and then I hit enter, and that has filled in the formula for me of K2 colon K10. So that's saying I want the whole column from K2 through K10. And you can see in this case, we only have one set of data, one piece of data, one data point. So the population count is 1. Well, let's just imagine we had a little bit more. So I'll just fill in some numbers here, and you can see the population count has increased because it is looking at that whole range of K2 to K10. And one neat trick, if I click in the formula here in the formula bar up at the top, it'll highlight the cells that it's looking at. So that's a nice way to just error check your formulas. You can look at them and make sure that you've really got the data that you're looking for. Okay. And you can do this as well for some of the other descriptive statistics that we talked about. So let's suppose we wanted the mean. We could say equals average, open parentheses, and I would select the range of my data again. I'm going to use that same K2 to K10, and that would tell me that the mean of this data is 5.48. Okay. Now for your lab report, of course, we always want you to create a lab report that's standalone. The whole idea is that somebody would be able to read your lab report and actually figure out what you did and be able to recreate it from the lab report. Okay, so you're going to take screenshots of the data that we're using. You're going to show your calculations here, and then you're also going to show what the formulas are that you used. And there's a couple of ways to do that. I think one easy one is if you just leave off the equal sign and copy the formula that you have here and put it in the cell next to it. Whoops, I put it in the wrong cell. There, so I copied it and pasted it into the cell next to it. So that would be one easy way to show the formula that you are working with. Okay. All right, let's go back and look at the lab again. So you're going to do this for all the data that we just said: population size, the lowest value, the highest value, median, mean, mode, and the population standard deviation. Okay. Then you're going to create a histogram for the density column from this same spreadsheet. Okay. And it needs to be properly oriented and pasted into the lab report, and be sure to label all the appropriate parts of the graph. And when you create the histogram, you're going to want to calculate the number of bends to use. Okay. So to do that, you're going to come back to your data set and look back at the material where we talked about how to calculate this. But essentially, you're going to figure out what's the range, meaning the largest value minus the smallest value. That's going to give you the range of all of your data here. And then you're going to divide that by the square root of the population. So you're going to take the square root of the population to figure out the bandwidth that you should have. Okay, so let me say that a little bit more clearly, and I think looking back at our class material will help for that. So for your histograms, what you want to do is determine your smallest and largest values, find the range of the data, which is the largest value minus the smallest value, and then we want to figure out how many bends should we use. Now, note no fewer than 6 bends. Okay, so if you calculate fewer than 6 bends, you're going to raise it up to 6. And a good rule of thumb is that the number of bends is equal to the square root of n, okay? So then your bend width is going to be equal to the range divided by the number of bends. So let's imagine that your range was 12. You know, your numbers went from maybe 2 to 14, so the range is 12. And let's say that the number of bends is 6, because we said that was our minimum. 12 divided by 6 would be 2, so each bend would be 2 wide. Okay, and that'll help you to figure out how large your bend size should be. Okay, so to actually do that now, what we're going to do is select the data that we're interested in, and we are going to insert a chart like this. Okay, and we need to tell it what kind of chart. It comes up automatically as a scatter chart. So if you click on that to the right here and scroll down, you will see histogram right here. See where it says histogram chart? And you can click on that and it'll automatically create some number of bends for you and some bend size. And so you're going to want to modify that. If you go into customize a histogram, Then let's see. I think it's customize the chart. Let's see, it's been a little while since I looked at this. Here we go. Customize the horizontal axis. And so you can tell it what do you want the min and max to be. And if you go through here, you can figure out as well how to set the actual bin size that you want to use. And so that you'll be able to use. I hear the bucket size that you want to use. You see how it's set to auto right now. You can use this to customize it. You can choose one of the values that's here, or you can type in your own value and it'll change it based on that. Okay, so you're going to customize it so that you get the right number of bends for your histogram. And you're going to explain in the lab report how you did this, how you actually calculated each of the various statistical values that we talked about, how you calculated the right bend size and number of bends for your histogram. And then you're going to take a look at what do the results indicate to you? Are there any outliers? Did you discard them? Did you keep them? Why or why not? Were there any assumptions or limitations in the data or the way that it was gathered or the way it was measured? Are there any surprises in the data? Do you think the results you got are reasonable? Is there anything unexpected? Any conclusions you can draw, looking not only at your own line of data, but across the whole class, any interesting conclusions that you can draw or things that you might want to continue to investigate if you had an opportunity to go further with this lab. Make sure you refer back to the lab report formatting guidelines and create your lab report actually using this lab report template. Okay. Same thing as before, you want to click that use template in the upper right corner, and that's going to make an individual copy for you that you can rename and organize in your My Drive the way that you want it to be. Okay. And just some reminders, include a clear screenshot of the density data. Take a screenshot of each of your histograms. Make sure everything's labeled well. Include your calculations for the number of bends and the width of each bend. And then provide a screenshot showing the calculated descriptive statistics and the formulas you used for each of these. Okay, and one final reminder to follow all the instructions in the lab report formatting guidelines. Okay, that's it. Have fun with it.